Okay, get this. What if you could teach a robot a new skill just by letting it dream? Sounds like something out of a sci-fi movie, right? Well, it's actually the new reality that NVIDIA is building with something called Project Groot, and we're going to break down exactly how they're doing it.
So how do you teach a robot to do, well, everything? I mean, it's one thing to program a robot for a single super repetitive task, like on an assembly line. But how do you teach it to be a generalist? To actually reason, plan, and act in our messy, totally unpredictable world, all from just a simple command? This has been the billion-dollar question in robotics for ages, and honestly, the answer has been pretty elusive. Until now.
Yeah, for a long time, the answer was, frankly, it was painful. Just imagine having to physically grab a robot arm and guide it through a task. Not just once, but thousands upon thousands of times. This old way of doing things, real-world training, is just agonizingly slow, it's super expensive, and you just can't scale it. It's been the single biggest bottleneck holding the entire field of robotics back.
So what's the big breakthrough? What's NVIDIA's new approach? Well, it's to pretty much bypass the physical world entirely, at least during the initial training. Their solution? You guessed it. Let the robots dream. And no, I'm not just being poetic here. We are literally talking about generating millions and millions of virtual experiences.
All right, so before we get into the nuts and bolts of how these dreams actually work, let's just take a quick step back and look at the training problem itself. Because to really appreciate how elegant this solution is, you got to understand the sheer scale of the challenge they're up against.
And this really lays it all out, doesn't it? The old way versus the new way. On one side, you've got human demonstrations. They're expensive, they take forever, and it's just impossible to scale up to the millions of examples a robot actually needs. But on the other side, synthetic data. We're talking about computer-generated scenarios that are fast, you can scale them infinitely, and they can be incredibly diverse. You can even dream up situations a robot might never see in a lab, which is perfect for preparing it for the unexpected. And that right there brings us to NVIDIA's big idea, synthetic dreams. This is where we stop talking about the problem and start talking about the magic. And believe me, it's powered by some truly groundbreaking stuff.
So what exactly is a Groot train? Think of it like a blueprint for creating all that synthetic data we were talking about. A developer can start with just a single picture of a room and a simple command in plain English, like, hey, put the apple in the bowl. And from just that, the system can generate a massive number of virtual scenarios, these are the dreams, for the robot to learn from, all without ever touching a single real apple or a real bowl. It's pretty incredible.
Okay, but it gets even cooler. See, not all dreams are created equal. NVIDIA actually came up with two different kinds of synthetic experiences, passive dreams and lucid dreams, and each one has a very different job to do in the training process. The big difference here really, it's all about control. Passive dreams are generated automatically from that picture and text command we talked about. This is how you create data on a massive scale. But for trickier, more complex tasks, a developer can actually jump in and take direct interactive control. They call it a TAO, or teleassisted operation. It's almost like a developer is a puppeteer, guiding the robot in the virtual world to create what they call a lucid dream. This is absolutely perfect for fine-tuning those really specific or difficult skills.
Okay, so the robot has had all its dreams. Now what? How do you actually get that knowledge out of the virtual world and into a real-world robot? Well, NVIDIA has built this really clever pipeline to bridge that exact gap, taking it from dream to reality.
It all breaks down into a really clean three-step process. First, you train the model on thousands and thousands of those synthetic dreams. Then, you evaluate it in a super high-fidelity simulator that has real-world physics. This is the crucial reality check, and only after it passes all those tests is the skill finally deployed to an actual physical robot.
And there are three key tools that make this whole pipeline work. You've got the Groot model, that's basically the robot's brain, the AI that's actually learning from all these dreams. Then there's NVIDIA Cosmos, which you can think of as the dream factory. It's the platform that churns out all the synthetic data. And finally, Isaac Lab. This is the testing ground, a hyper-realistic simulator that gives the model a tough, physics-based reality check before it ever tries to move in the real world.
So we've seen the how, right? But what about the why? Why go through all this trouble? Well, this incredible technology isn't just about teaching a robot one new trick. No, it's about a fundamental shift towards a whole new kind of robot, the generalist. Yeah, the end goal here is to create generalist robots. Just imagine machines that aren't stuck doing one single pre-programmed task on a factory line forever. We're talking about robots that can actually understand what we say, see and comprehend the world around them, and then figure out how to complete brand new tasks they've never seen before in pretty much any environment. That's the dream.
And look, this isn't some far-off sci-fi fantasy. As NVIDIA themselves put it, with this technology, generalist robotics is within reach. And that is a really powerful statement. It suggests a future where these capable, adaptable robots could become a totally normal part of our lives. And it's all being accelerated by this incredible dream-to-reality pipeline.
So, that leaves us with one final, pretty fascinating thought to chew on. If you had a robot that could learn almost anything just by dreaming about it first, what would be the very first task you would give it?